You would start out at the very beginning of 10 feet, get your pulse count numbers, travel the 10 feet, get your pulse count numbers again, which is essentially all your virtual world data, and then you will convert those pulse counts the same way it did whenever it did the limit switches, but you're just having to manually do it. Now the constant is you punching in the constant and putting that into your scaling. Now that's you punching in the constant to come up with the ratio of pulse counts to physical space. Now I want to go ahead and dive into vision systems a little bit because they're slightly different in the way that they build their relationship to the world. When it comes to vision systems, at least for vision location, you're going to use what's called a calibration grid to calibrate the camera and build its relationship to the real world. And the way a calibration grid works is essentially they are a dot grid. So essentially all a dot grid is a grid with dots on it, and those dots are set to a particular increment apart from one another. So you may have a dot grid that is 10 millimeters between dots, or 20 millimeters between dots, 30 millimeters between dots, and then you're going to have the hundreds of dots. And generally somewhere in the corner of that panel or something like that, it's going to tell you how far apart the dots are spaced. And essentially what you do in a 2D vision application where you're locating something on a flat plane is you're going to set that grid as close to that workpiece as possible